Okay, Jyotish, we are live. I'll just send you the link. Okay, I'm just going to send you the link. You can mute yourself, Jyotish.
Yeah, I can see. Yeah, I can see that. Okay.
Okay, you can see it.
Yeah.
Again, I'm sending you the link.
Mhm.
Okay, the previous session there was some issues, so I had to close that down. We'll wait for some time so that everybody joins.
Sure, sure.
Let's see whether people are coming now. Yeah. So yes, many people are joining.
Yeah.
That is fine. Make this private. Okay, hello guys, everyone. I hope you all are doing well. Welcome to today's session. And in today's session, we'll try to see how we can create deep learning model using TensorFlow JS. So, hello Krish, I'm glad to see you. Hello everyone. I hope everybody is able to hear me and Jivitesh clearly. Again, we have Jivitesh today. Thank you,
Yep.
Jivitesh, for coming for this session again, and for sharing knowledge with many people as possible.
Thank you.
So,
Yeah. And
yes.
hello, everyone.
Go ahead. Go ahead.
Yeah. Hello, everyone. So we are wish you to have a pleasant evening because nowadays evening are so good, so everyone can enjoy that.
Yes. So we'll just start in another 2 minutes, Jivitesh, max.
Yeah. Sure.
Okay, Jivitesh, I think 100 people have joined. I think you can
Mhm.
start, right?
Okay. Yeah. Sure. So yeah. Hello, everyone. So today we are going to basically talk about TensorFlow JS. TensorFlow JS is a JavaScript library. Basically whatever the things we do in a TensorFlow that can be done using TensorFlow JS. And the thing, like whatever the models we have created, the PV models, H5 models, I can say PyTorch model, any of the models we can convert it into a format so that it can be used inside a JS code. So each and every model we can convert it. So today we are going to see the same thing. So we'll be going through that. We'll first try to see that if you remember that last time whatever the code we have discussed for the Docker, it's ANPR model, the same model we have, the PV model, and then the PV.txt file was there. So we'll try to cover, means convert that PV model into a JS format, and then that JS model will try to use in a simple means HTML, CSS, and JavaScript code. So there is no machine learning, no Python there. So machine learning is there, deep learning concept is there, but we are not using any Python coding here. We are just have the model, the PV model, any of the model you can use. So you are not supposed to have the same model and all those things. Any of the models you can use, and for the sorry, and the same model you can convert into a JS, and that JS model we can use into a HTML and CSS JavaScript code. Now, why we need to have that first at the first place? So let's say I'm talking about client side deployment. Client side deployment means, if you remember that last time, some client side deployment means the whatever the user is able to see, means the UI front end I'm talking about. So let's say I wanted to do ANPR. If you remember the last time we have discussed the ANPR code, so there we have tried to share that, send the picture image, and that image it will be processed. It will recognize the number plate, will crop that number plate, and that number plate can be passed to. Yeah, Krish, you have to say something.
Yeah, I've just shared the code in the GitHub in the description, Jyotish. So you can also announce that. Okay, just reload the page. You'll be able to see
Sure,
the
sure.
GitHub.
I can see that. Yeah,
Yeah, perfect. You can continue.
yeah. Yes, guys. So Krish has shared that GitHub link for the code which we are going to discuss today. It's like the last class, everyone was asking that, okay, can you share the code which we have discussed? So we make sure that we are sharing the code before we are going to discuss the same thing. And we have shared one drive link as well, so that you can download this PV model. So PV model was actually heavy size, large size, so we were not able to upload on a GitHub. So that's why I have shared it in a drive so that you can download it from there. So we have a JS code on a GitHub, and then PV model we separately you can download from the cloud. So this drive. Yeah, so I was talking about this JS code. So what, why we need to have the first of all the JS code. Python is doing well. Python, we can do everything, each and everything in a Python, and then why we need to have it first of all JS one. So the point here is, let's say you have some like the ANPR I'm talking about. So ANPR code, what was all about is, last time if you remember that we have discussed that we are trying to pass the image. I'll just show you the which image I'm talking about, so that will be easy. Krish, are you there?
Yeah, Jivitesh,
I
I'll
think yeah.
yeah, yeah. Now you can share.
Okay, thank you. Okay, so I think you guys are able to see my screen. So I'll just try to here. So what I was saying last time, if you remember that this is what we were trying to do, that we are trying to pass this particular image, or if I'll show the some other image itself, this image itself, we are trying to pass to that our system, whatever the code we had, and that code was able to detect these things. Means it was able to. I'll just try to mark it. It was able to detect the number plate. First, recognize this number plate. It was able to crop that particular part, and then this particular part is sending to the OCR part, and the OCR will try to extract the number from these images. So this is the flow which we were trying to do last time. Now what my requirement is, now what that time what is happening, my code is also running on the same machine. I'm trying to hit this from the same machine. Let's say I wanted to do some real time prediction, and wanted to some do this project, and I wanted to implement in some real time environment. Real time environment, when I say, let's say I'm talking about the traffic signal. So there I wanted to implement it. Now how it can be done, I'm not going to put a system there, so that system can process this request and then send it to the, and then do the streaming and all those things. So live it cannot go. Basically the my point here is I wanted to do it live. Whenever I'm just moving vehicle is able to come into the front of the camera, it is able to detect the number plate, crop it, and then pass the OCR. Okay, this is the number what we have. So this real time thing what I have to do. So now I want to do this a traffic signal, or let's say we have a smart parking system there. Generally that is the private parking. So generally we go there, we'll pay some amount of money, and then we'll park our vehicles there for some time, and then after that we'll collect it and we'll go back. So this kind of a system. So there also we wanted to mount this kind of a system, so that at the end the business goal was, at the end we need to have the whole count, how much vehicles came and what was the number of this vehicle. So if we have the number of the vehicle, we can do so much things. We can extract the user information, we can get the means what time this vehicle came, everything we can have. So now how the lifetime, let's say this smart parking, there just one guard used to sit, and then area is there. Now how we can do the live streaming, how we can, there's two option in that case. Either we have to record the whole day video, and at the end of the day we have to process it. So this is the one way. Second way, what we have to do, we have to put a computer there, and then we have to get the stream, live stream with the CV to video capture thing, and then we'll keep on doing the prediction. This is the other way we have to do. But we cannot put let's say I have a 10 parking system, I cannot just set up, put the 10 high processing power systems everywhere. So I need some centralized system, or just some lightweighted system where I'll just pass these things and it will be done instantly. I don't need this kind of any bulky system there. So in that case, we'll try to do this conversion of models in a some lighter weight way. So like it will be easily consumed anywhere, and should not needed a huge system. So if just the guy is just having a normal system, normal computer, the one if he used to do this marking and allotting the slots and all these things, he can able to do it. So what we can do, we'll try to mount a camera there. Okay, This the whatever the CCTV camera used to be there, that will be there, surveillance camera, and then whatever the feeds we are getting from the camera. So that feed I'll simply have it in a TensorFlow JS. TensorFlow JS is just need a browser to execute, just a browser, nothing else. It doesn't need anything extra. So just a browser if you have, and you are good. So I'll just need a browser there. So though the streaming, I can pass it to the browser and it will process it. So these are the lightweighted thing. First of all, it is fast, because at the same time, if you're trying to do it as a server thing, you have to capture the image streaming and then pass it to the server. The server will do the prediction and then it will respond back. So this is a long process. It's a time taking thing. And again, the costing wise, it's a huge. So real time system, this JS is a very useful. I don't know if you guys have seen or not. I think Krish has already uploaded a video on a JS, so you can just go and check his playlist. So TensorFlow JS is something which is useful in some cases. I can say very useful. Not only useful, it's a very useful.
Jitesh, I have not uploaded anything with respect to JS. So
A teachable machine was that
yeah,
that
yeah, yeah,
thing.
yeah.
Yeah,
Teachable machine I have uploaded. Yeah.
yeah. So teachable machine was the same thing which he uploaded. So that we are trying to have the JS thing and all those things were happening. So you can check that out. So anytime you can check that. So this is the use of JS, and I'll show you that how you can convert your PV model into a JS model, and then we can have a simple snippet of code which index means HTML, CSS, and JavaScript, which I have already shared with you, and we'll try to use that model. So the same model which we have used last time. Here we are not trying to do the OCR, and just we are trying to do this detecting a number plate, recognizing it, and just trying to mark it, trying to draw a bounding box there. So now one more thing I'll try to show you is people are confused. Like, okay, I have to write how to write OpenCV, how to write all the things in a library in a JavaScript. So I'll just give you a quick recap, not a quick update. OpenCV. OpenCV is available in JS. OpenCV.js. OpenCV.js. So it is already available in JS. Anytime you wanted to check, you can check that out. It's already there. Now coming to pandas. Pandas JS. Pandas is available in JS. Coming to NumPy. NumPy is available in JS, NumJS. So each and everything, more the basic thing, I can say the most important thing, that's OpenCV, NumPy, and Pandas. Three things you generally need. And image processing, doing this image capturing and all those things already available in JavaScript. There are a hell lot of resources are there, Canvas and all those things. So many things are there. So this is already there. So you don't have to worry that how to write the camera, how to get the capture a video, how to pass it to other API and call this function, all those things. So JavaScript is capable of doing all those things. So OpenCV, Pandas, and NumPy, those are three major libraries which you generally use in all the deep learning models. This is already in JS. One more thing, the OCR thing, like last time we were talking about for the complete code, number plate one. So for that, there is a library called Tesseract. Tesseract is available in JS. So each and everything is available in JS. Anytime you can go and use it. Just you need to know that how well you can use it, how production, how you are able to make it productionize, how you're using in the real time. So this you have to decide how you are going to use it. But these things are available. How accurate your model, how accurate your prediction, and all those things you have to make sure. But this can be used in a JS format. So everything is available. You don't have to go to Python for any keys. And this is again a lightweighted thing. Okay, so this is what we are going to talk about today. So here I have shared that GitHub link for you, for my GitHub link for that code. And this is the simple code which we are going to do. So this is the TensorFlow JS object detection simple, where I have this model. This image I'll pass it and it should detect a bounding box to the number plate. I'll just run it, which should show me the my code is running. Yes, it's running. Okay, npr, I think file not found. Okay, just a minute, I need to check something. Some file is missing there. which file is which. So okay, just okay, I think some file I need to check. I'll try to execute it from here. I'm just here. I'm not doing anything simple. I'm running a Python server. So there is nothing new here, which you should be worried. This is how you can launch a Python simple local server. And generally used to do this with the Flask and all those things, but here also you can do it in this way. So just I'm trying to do the same thing. I'm trying to reload this page. Okay, now I'll try to process the same image. Okay, so if you can see that now here I am able to get the number plate, and if you can see that this, sorry, bounding box is there. Now here you might have noticed that it's mentioning there a person here. It's a person here. Why? Because I have used the old pbtxt file, just a simple cocoa dataset pbtxt file I have used. So instead of that, I can use that my file itself, and it should be good. I'll show you that where it's coming from and how we can change it. So there's nothing this new in this one. So if you can see that how quick it is, how lightweighted it is, and this can be done real time. So in this time, what we have to do, we don't have to send any data to the server. I'm just getting the image in a browser. I'll process it there itself. I'll pass it the result. So I don't have to wait to just send it to the browser, and then browser will come back and then update that, okay, this is the result I have. All those things we don't have to do. It's a simple process. Now I'll just try to show you one more thing. So here, if I'll just show you NPR model. So this is the PB model and the pbtxt file which I have. I'll try to convert it into a JS first of all. Now how to convert it into a JS first thing. So I'll just try to remove, increase the size as well. So just give me a minute. Okay, now I think it should be good. So now I have to create a JS. I have to convert for the model into a JS first of all. So what I have to do, I'll just go with the flow. I'll just try to create a separate environment for that. Like I always prefer, and I keep telling everyone to do the same thing, so it will be better. Because I'm just creating a separate environment here. tfjs conversion 2. I might have the name is conversion 2 because I might have the other environments. So I'll just have it here. I'm just trying to mention the Python version. Okay, it's already there. So I'll just try to have another one. 3. Yeah, we are good. Okay, yes. Now I've created this environment. Now this is completely new environment. Nothing is there. So I'll just try to activate it. So in this environment, I have nothing. Just now I have created it. So when we use TensorFlow Js, we don't have any backend model, right? Like when we deploy, no, we don't have anything like that. Everything inside the JS itself. So you don't have to go for any backend processing. Okay, now here I'll just, I have to install one thing first, pip install TensorFlow Js. This is the one thing which I have to install. So I'll just do the pip install TensorFlow Js here. And one more thing, not only PV model, even it, like I told you that in the beginning itself, PV model, H5 model, PyTorch model, TF hub model, any model which you have that can be converted into a JS. So there is nothing something like that. This model we cannot convert it. So PTH we can use conversion with ONX, and then we can do the conversion. So everything is available. You can do it. Now pip install TensorFlow JS is done. Now what I have to do, I have to just do the conversion command. So I'll just show you the conversion command what we have. So here I'll just try to have this. I'll try to copy this one. I'll try to paste in here. Oh, sorry. Hold on. I need to make it in one line. So just give me a minute. Okay, yeah. I'll just show the commands here. So here, if you can see that this is the command basically we are using, and pickle model. Yes, that's a very generic question, guys. So I can understand that. And here is your answer. Pickle JS. Here you go. So anytime solution is there, so you can just go ahead with this one. Okay. Okay, coming back to this one. Okay, so now this is the command which I have. I'll try to share this command in a chat itself so that everyone can get it. Just opening this YouTube for now. Just give me a minute, guys. So I'm just sharing this. Hold on. I'm just sharing this chat here. So here you go. Okay, I think it's showing this. Not able to have all these commands here, so no worries. I'll just try to share another link with you. So you can use this link and you can come here and copy the commands. So just sharing this in a chat window in a YouTube chat section itself. So here you can get it. And there you can go and just copy this command, the TensorFlow JS command, which I'm using currently. So anyone can go here and just don't try to remove it. Keep it there so that everyone can use it. Okay. Now I'll try to explain this commands here itself. Okay. Now here I'm using TensorFlow JS converter. This is the command which I'm using. Now I'm using input format. What is my input format? So as you know that PV module is how, okay. So now the input format, the TFJS converter I'm using, that's a command, basically a TFJS command, TensorFlow JS. We call it as a TFJS. Input format is what is my model format. So now it's a frozen model. Like if you know that from the CKPT file, we try to do this frozen the model. So this is the, then we got the PV model. So this is the frozen model format we have. Now output nodes. So basically this output node means that what all the thing you need, what all the predictions you wanted to have. So this output node names, basically you have to define it here. So detection boxes, I need a bounding boxes. I need the score for all the predictions, whatever the boxes I'm getting. I need the class names, and I need the number of detection in one frame, how many object is detected. So this is the number of detection. So this is all the things which I need to get in a model, in the TFJS model. So this is the output node, what all the things I need. So all those things we have to in a quotes and with the comma separated values. So this is one box, detection boxes, like the bounding box we need, scores I need, then detection classes I need, and then number of detections I need. So these are the things which I need. Okay, now, so now after that, I just need to pass the path where my PV model is sitting. So for me, I'll just try to change the path accordingly. So wherever my PV model is sitting, I just need to pass the path of that model. After that, I have to pass the path of my location where I wanted to store the model. So this also I have to pass. Okay, so I'll just pass any name you can pass, whatever name you wanted to have. and then we are good. So now in that case, what we can do here, we are coming and I'm just inside this folder. This is my npr pv model. Inside this one I have pv and pvtxt files. I just try to have this name itself. I'll go there. I'll try to change this name, the location of my input model. So this is my input model path, and then the model where I wanted to store it. So I'll just have tfjs YouTube. Okay, just a folder name I wanted to have, nothing else. And TensorFlow Js from PV2 is I'll just try to have a PV5 for safer side because I might have other things. So here I'm just trying to explain it again. What are the things I have? TensorFlow Js converter. This is the command. Input format. What is your input format model? So for me, I'm passing the PV model, so it's a frozen model. So that I'm trying to pass here. Output node names. What all the things I wanted to have? Means what about the things I wanted to get the means output. So detection boxes I need this detection scores, I need the detection classes, I need the number of detection. So all four things I need. So this output node names is having this particular parameters, and then the input model path, and then the output model path. This is the only thing which I have. So far just try to check your comments. Okay, so execution speed will depend on client CPU on which browser is running. Yes, Sony, you're right. And what will happen to the heavy models like object detection and will the model mobile browser support this TensorFlow JS? Yes. So Sony, there is an option where you can trim your weights also. So trim your weights, I'm saying when I try to convert this model, so there's other options that where you unnecessary weights you can trim it so that your model can be a lightweighted model again. So that can be done. There's nothing like we cannot do it. So yes, we can do it. What detection scores and detection classes? So whenever I'm trying to check something, when I'm trying to predict something, let's say I'm predicting it's a person, it's a bottle. So whenever I'm trying to do any kind of a thing, so now I wanted to know that model will give you the accuracy, how much percentage I'm sure about this that it's a bottle. So this is the scores basically, and the classes like okay, this is bottle, this is a person. So like these are the classes. Okay, so this is what we have here, and then I'm just trying to convert it. If you can see here, I'm provided a npr pv model 5 as my output folder name. If we go back here, I don't have any pv model 3 till I have. After that, I don't have any model there. So I can have this one now, 5 model. So I'll just try to hit enter here. So now my model is getting converted. It will be a one JSON file and other is a bin file. So basically JSON file will try to hold the architecture of the model, complete things, and then the model file, the bin file will try to hold the weights. I'll show you that what I'm talking about. What will be the speed on mobile as compared to browser? So basically this depends upon the how optimized your code is, how optimized you wrote your code for the JS itself, and how optimized your model itself. So all those things depend upon this also. So we cannot directly say that every model will be have like the way it should be like this way, but yeah, it depends. How we can train model with detection boxes? How we can train model with detection boxes? This we do in a. I think you need to check the data science videos that object detection. Chris channel. Chris is already having those kind of videos. So I'll just go here now. If you can see that there's a PV3 and the where is that PV5? Yeah. So here is the PV5 model. Oh, sorry, I'll just yeah. So here, if you can see that this is the PV5 which we have just created. Inside that there is another folder called TFJS YouTube Converter JS model. And then if I open this one, these are the models we have for the JS. So these are the complete models we have for the JS. If I'll try to check the size of this one, it's 73 MB right now. But you can further decrease it. We can further reduce the size also. That can be done. Okay. Inside that, there is a called JSON file and others are called bin files. So bin files is basically trying to hold your weights, model weights. Okay. And this JSON file will try to hold the complete architecture of your model. So if I just try to increase the font size, oh, it's too large. Yeah. So if you can see that what we are using in which layer in the neural network, everything is there. What is the D type, data type, tensor space, all those things are mentioned here, everything. So just a basically architecture model, I can say it will hold the architecture. And the bin files is just a holding a weights for you. Okay. So this is what we have here. Now what we have to do is the code which I have provided you, so the same index.html code, this one. So I'll try to open in Sublime. Here I'll try to, so here what we have to do right now, here the model path, sorry, not in the JS file, actually I have to change the model path. I have to change inside the JS file. So I'll just open in this one, sublime.txt. So here if you can see that I'm using NPR plate detector v2. Instead of that, I have to use the new model which we have connected just now. So I'll just try to have this one, this file folder name, and then inside that there is another folder called this one. So I'll have that name as well there. Okay, now it's looking for model.json. So make sure, one more thing you need to make sure is the wherever your model.json, in whichever folder, make sure your bin files are also sitting inside that. So it will directly take it there. Directly try to load all those files. I'll show you that when I'll say that it will load it from there. I'll show you how. So now I have everything here. Everything is good. I'll try to again go back here and try to launch this. Python server was running, so I'll just stop it. I'll just try to create a new, open a terminal. I'll just try to launch a Python server, simple Python server. So I'm just launching a Python server. If you are not able to, if you are not launching this Python server, you can use the Jamp also. If you want any PHP server, you can use, because it's simple as JS and HTML. So, sir, input format, sir, can we get any other input format model? Yes, the H5 model. So H5 model is there. That is a KRS model. So that is the other format you can have. That also you can use it. Now there is a TF hub models. So there are so many things is available. So you can use any of that. Okay. So now again, I'm launching this Python server. My code is running on port number 8000. I'll just go back to the browser. Here, I'll show you that how this things is loading. So basically, I'll try to have it clear everything. I'll try to load it. Okay, so and I'll show you that when I click on run, right now it just loaded the JavaScript, localhost, and all those things. Okay. Not this one, this area, if you can increase. Okay, yeah. I will increase this little bit of size for you so that you will be able to see it. I'll just clear this console for now. Now when I click on run, so if you can see that it's trying to load all this. First is loading this model.json. You can see the path. It's from PV5. And then the folder name which we have provided, it's loading the model.json. Then all the bin files, it's been loaded from there. So that's why I was telling you that wherever your model.json is sitting, no voice. Is it for everyone, guys? Krish, is my voice audible?
Yeah, Jivitesh, your voice is audible.
Okay.
Don't worry about it.
Yeah, so thank you. Here, so what we are saying that, okay, just make sure that wherever the model, because in the JavaScript file, if you can check that out, we have only provided the path for model.json file. So I have not provided the path for bin file, any of the bin file. So by default, this system is considering that wherever this model.json is sitting, all the bin files is sitting in that itself. So there is no gap in that. Okay, so make sure that the model.json and all the bin files which we have created should be inside the same folder, should not be at any other location, otherwise your model will not able to execute. Okay, so this is one thing you need to make sure that the model bin file and the model.json should be there. And we can see that we have a status code for 200 for all those models. There can be, instead of this local model also, if you just wanted to do a check, you can use the TF hub model also. So there is SSD mobile net TensorFlow JS. If you look for, you will check that out, and they'll provide a complete direct link here, and it can be used from there also. But right now we're trying to do so how we can do it from scratch, how we, if we need to convert it, how we can do it. So this is what we are trying to do here. Okay, now I'll show you that. Okay, this model is converted. I'll just try to reduce the size. Okay, so tensor, okay, I got some error in this one, so I'll just try to tensor. After this, some JavaScript error I'm able to get. Okay, I'll just try to change this one to this model itself, and I'll try to show you the one more thing here in the JavaScript itself. I'll show you that how this things is happening. So I'll just try to load this page again. If I'll just go to index2.js. So here, this is the car.jpg. This is my image name, a static image I have provided. Okay, this is just a static image we have provided for demonstration purpose. But in the real time, you can have it as streaming image itself. It will be continuously streaming. That can be done. Okay, so here a simple image I have provided, and then this is the model.json file. I'll try to show you that how the prediction is happening basically. So this is just a JavaScript code, so there's nothing kind of rocket science here. It's simple, easy. Simply, it's just as simple as even simpler than Python, I can say. So if I'll just show you the JavaScript code, we don't have just this as a const. I'm creating a variable here. These are the variables, and this is how we can define a functions here. So there is a simple function. If I have to define, I'll just write here a function and the function name, parameter, done. Simple. There's nothing rocket science here. JavaScript is also very easy language, so you can just if you just spend 1 or 2 hours in that, you should be able to, at least you should be able to understand the code, the flow, and all those things. Okay, now here again, so this is I think you guys have remember that debugging thing, how we can do the debugging. So this is the debugging we are doing in a browser itself. So this is also, you can say, as a client side debugging. So that also we can do. So this is one more concept you can just try to have, that how we can do the debugging. So for having a breakpoint, if you should be remember this, having this aware about what is breakpoint and all those things. So but you can just click once here and the breakpoint is added. So now once I click on run, so now my model is being loaded here. Now once this flow or cursor will reach on this line, it will stop. So right now it's still loading the models. Now you can see that my code is stopped here. Okay, so this I'm using here from last I can say whatever the things we have loaded so far, now it's done. Now my code is stopped there. The way we are doing the debugging PyCharm, same way we are trying to do here. There's nothing new. Each and everything you can do here, like the variables you can see, everything can be done here. So now if I can see that I have a vehicle model, the model which we have loaded just now. So if you can extract it, you can see all those things are here. Everything you can see, what are the layers and all those things. If you wanted to see it, there is a concept called evaluate expression option is there in a PyCharm. So here also we can do the same thing. I'll just remove this other parts. Now inside this model, you can see each and everything, how this model and all those things, each and every layer, if you wanted to extract like the Netron we do, each and everything we can do here. Everything you can see, whatever the things inside the model. Okay, so each and everything is available here. Now I am doing this vehicle model dot detect image and then the result. So if I'll just try to do a step by step again, there is an option here in the browser, step over. Step over name is same everywhere. In PyCharm also will get the same name, step over. Here also you are getting the same name. I'll just do here. I'll just try to have it. Now we got it here. Now this bounding box and all those things we got. I think I should show you one more thing that. Okay. I'll just try to show you that how what all the things we got. So here number of detection is 1 because in this complete image we have just detected a single image, nothing new, just a single image. So that's why I'm getting number of detection is 1. This we are trying to print it from here. So number of detection and then result dot length we are trying to print. So that will give me that how many objects has been detected in this image. Now I'll just try to do the prediction for you again. So let me do that. Now here I have breakpoint here, so I'll just show you the results what we are getting. Yeah, I'll just click on this. Okay, now if you can see that this is a result variable, then this we got the output. So I'll just try to display it here for you, result. So inside that, if you can see the 4 things which I was talking about, we are getting bounding boxes, we are getting classes, which class it is. Now it's a person because I'm using the Coco dataset pvtxt file. Bounding box I'm getting x min, y min, x max, y max. I'm getting the class, I'm getting the accuracy, I'm getting the length. What is the length of this one? So everything we can get it here. Now the same thing we are trying to display you here. Now the person thing which I was talking about, I'll just try to show you. Just a minute. Now the person, why it's coming as a person, because I am using the pvtxt of a Coco dataset. So if I'll just try to show you that, instead of that, if you can just simply go here. Here if you can see person, so I'm using the pvtxt file of a Coco dataset. I think you guys should aware about the TensorFlow, that Coco dataset. So I'm using this for a Coco dataset. So all those 90 classes are available here. That's why it's showing me the person. If I'll use my pvtxt file instead of this one, I'm good with having the thing with the classes which I'm looking for. So that can be done. But for now, just to showcase you guys, I've used the same thing. In this one, you don't have to change anything up, just you have to change this class names. That's all, according to your file name. You will perform OCR on the number plot, not in this one. I'm not performing OCR in this one, but I've showed you that tesseract.js is available. We can use it, and you can use it and try to have it running on your machine. And you can definitely share with us as well if you are able to do it, because we are doing it for some other projects, but here I'm not showing you that itself. Okay. So this is the complete flow of TensorFlow JS. Now I was talking about that TF hub module and all those things. So there is, instead of, I'll just try to close this one. I'll clear it. When I was talking about this converting this PV model to JS, I have showed you this one. Now there is a call TensorFlow JS underscore wizard. So there is a, if you run this function inside this TensorFlow, the environment which you have installed, right? So TensorFlow JS, if you just execute, it will give you the interactive UI. So there it will ask you for your input. If you provide your input, then it will process further. So right now it's asking for, if you are converting TF hub module, please provide the URL. So right now the PV model we have seen how we can do that. Now I'll just give you that for TF hub model. So let's say I'm just trying to get the TF hub model for TF hub models. I'll just try to have any of the model link there just to showcase you guys. Image, text, let's go for image. Yeah, so let's image classification. Okay. I'll just try to get this. Okay. Just use, and I just wanted to have the URL for that. That's all. Let's have this one. I've just provided. Let's see. It's a TF-fob module. Yes, it's a TF-fob. Now it's asking for other format also. If you can see that, it's asking TF-fob, or it's a Keras one, or it's Keras saved model, TensorFlow Keras, TensorFlow saved model, TensorFlow JS. All those options it will give you. So if you don't want to go with the commands which I have shared with you, you can have just a TensorFlow JS widget here, which I have shown you. Simple. And then you can, I'll just try to mark it for you. So instead of going with complete method, sorry. So instead of going with the complete flow, you can just have this command itself and it will give you the options. All those options you can see it and you should be able to do that. Right now it's a TF hub module. If it's so I'll just hit enter here. No compression. I don't want to compress it, but if I wanted to have, I can do it. So options are there. If you can see that. Accuracy loss is there, minimal accuracy loss is there. So I'll just go with this one. So it's asking please enter the layers to apply flat float 16 quantization to a smaller minimum accuracy trade-off expansion with like weights and all those things. So this actually before doing these things, you should be aware about that what is the model architecture you're doing. So that is at a beginner level, it's not suggested to change that anything inside the model. But if you are good with that, if you know the model architecture, if you know that what layer is doing what and all those things, if you're aware about, then you can definitely go ahead with this one. Okay, so I'll just try to show you this. Do you want to save the no? So I'll just try to show you the simple approach without any conversion. I'm just showing you that so that you can do that. But unless and until you're not aware about that, don't do it. So just TF, this is my TF of model. No compression. This is the size that is fine. And just go for yes, yes, yes. Sorry, which directory you want to save. So I'll just try to create one directory here. Hub model. I'll just have your same thing, have model. This output, so you want to overwrite. It's asking me that the folder is already there. So it's overwrite, yes. Now it's converting me. Convert, okay, I think I have missed something. I have attached something there. Sorry. Okay. Which directory you want to, okay, hub model. Yes. Okay, some error it's showing that model, I think the model link is not correct. Otherwise, this is the process we should be having. Let me check that out. TF of models link. I'll just show you this one. Hold on. I'll just use this TFJS. So I'll just go for TensorFlow JS. I'll try to, they have this TFJS converter. So they have that model link there. So I'm just trying to show you that TensorFlow JS. Yes. So here you can anytime check that out. Tutorials. What is TensorFlow JS? The Keras model. JS converter. Okay, so here TensorFlow, you can see that here, like the thing I was explaining you, TensorFlow JS converter, input format is Keras here. Now model.h5 and the output folder, whatever you wanted to have. Same way. And then this is the loading model, how you can load the model in a JavaScript. This is the loading model for a JavaScript page. I'll just check for the other ones. Models repo. So TFJS models are there. This is the converter. This is a converter also here. I'm just looking for a link, actually TF model link, so that I'll show you that how we can convert. Okay, so just I got it here, one. Okay, so this is the one we have. Okay, fine, I'll just show you this one. Okay, and I'll just again execute it. I'm just providing that hub model link. Hub model, yes, no compression. Yes, yes. Yes. Now if you can see that it's converting this hub model itself. This model I don't have on my local machine, but I am able to convert it. So TF hub model, if you guys are not aware, TF hub, they have already uploaded some models there, so you can use it directly with the URL itself. Now if you can see that they have converted, there's one model.json, then there is a, like the other things, the bin files are already updated. So if I just show you in the folder, if you can see, this is the hub models which we have created just now, and inside that you can see that model.json and all the bin files we have updated, and this all the same models you can use in the same way. If you, it's a classification, then there's a no bounding box thing, so that code in a JavaScript, you not need to process it. But apart from that, rest everything will be same for you. So just you will get the classes, and whatever the thing you need to do with the classes, you can do it. So I've showed you that how to convert PV, how to convert TF, but same way you can go for the H5 as well. H5 is very simple actually, so not this much of complications are there. So for H5 it's a straightforward, simple, this much command only this format is a keras, model location, output location, that's all, nothing else. Which model should use graph or layer model? Okay, yeah, that one actually. So when you show that, basically you can say that when you're using this detection model, the TensorFlow one, go for a layers one. Classification, you can go for the graph models. This is how I can suggest you. Okay, so that's all from my side guys for today. And if you have any questions, please do let me know. Otherwise I will be here to answer your questions.
Jivtesh, am I audible? Hello, Jivtesh. Okay, guys. So Jivtesh got disconnected. I'm extremely sorry about that, but I think you had an amazing session altogether. Any questions that you have, and probably this is just an idea to give you like how you can convert your deep learning model into JS. But I hope you liked it. I hope you were able to understand most of the things. I know there are a lot of complex things because I call people like this, and you'll be able to actually talk with us, understand what recent things are going in the resource center of the data science, right? What all good practices are basically going on. So thank you all for joining this session, and I hope you like it. Please do hit like for Jivtesh. And yes, I think some what idea you have got, but don't worry, in the upcoming videos I will be discussing step by step all these things. Slowly you'll be able to understand everything, right? So thank you everyone for joining, and I'll see you all in the next video. Okay, I hope everybody's able to see and hear me, right? So thank you guys. Bye bye. Have a great day. We'll see you all in the next session. Thank you. Bye.